Welcome back. Today we're going to dive into section 3. Section 3 is all about geometric sequences. So we're still discussing sequences, this idea of a list of ordered numbers. However, today we're moving on to a different type, where this time we have a common ratio. Okay, so instead of adding or subtracting something, we're going to be multiplying by something over and over and over again. Now, once you understand that idea, the formula itself for geometric sequences is actually very easy, okay? Probably easier than the arithmetic one. How do we start? Well, recursively, we're going to start by identifying our first term. You always need that initial condition in the recursive formula. And then what do? Well, we take the previous term and we multiply it by whatever every term needs to be multiplied by to get to the next term. So recursively, really easy. Well, explicitly is basically the same thing, okay? As long as you can recognize the formula, you start with your first term, and then you start multiplying by that rate, okay? Now notice here, just like the arithmetic ones, notice it's not n we're using, it's n minus 1 that we're using, okay? So just a little note, a commonality between the two is that you're using n minus 1 instead of using n. But this idea is going to be very, very similar, okay? To write either one, you need to identify A1 and identify that rate. And then remember, recursively, you're using an minus 1, and explicit, you're using n. All right, so, oh, I apologize for that. There we go. So let's dive right in and start working with some of these. So geometric means I'm looking for what am I multiplying by. This first example, I think it's pretty easy for you to see that you're multiplying by 3. Okay, to go from term to term, simply multiplying each one by 3. So recursively, the recursive definition, you always label that first term. So in this case, my first term is 2. And then what am I doing to get to the next term? Well, I'm taking the previous term, the n minus 1 term, and I'm multiplying it by 3, okay? Again, all you're doing is stating what you're going to do to go from term to term to term. The explicit formula. Explicit formula, you start with that first term, and now right away I start multiplying by that rate, but to the n minus 1 power. And again, the really nice thing here is you don't have to simplify, okay? Once you write it out, that's actually it already. All right, well, let's look at the next one, okay? Let's keep moving right along. So here, I need to be very clear about something. So most of you would see this and say, oh, I'm dividing by 2. However, you can't think of it as dividing by 2, okay? In these geometric sequences, everything actually has to be written in terms of multiplying. So dividing by 2 is the same as what? Well, it's the same as multiplying by a half, okay? So you absolutely need to make sure that you're thinking about those properly. Instead of dividing by 2, you really, really need to be telling me that that is multiplying by 1/2. Once you understand that, well, now the construct is going to be just the same. Recursive. Recursively, I need to label my first term. And then I need to say, well, I'm taking the term before it, and I'm just multiplying by 1/2. Explicitly, what does this look like? Explicit, I plug into that formula. I plug in A1, which in this case is 60, times R, which is 1/2, to the n minus 1 power. Now this next one might be a little bit harder, okay? The thing I'm multiplying by isn't as obvious, okay? So what I want to show you and point out is this right here, okay? If you know you're talking about something, um, something geometric, the easiest thing you can do is take the second term, divide it by the first term, and that'll give you that rate. Okay, so do a future term divided by the term before it, and that'll give you that rate. What I mean by that is here, maybe not so obvious what I'm multiplying by, but if on the calculator I check and I say, okay, well, -6 divided by 4, math bracket, I'm talking about -3/2. Okay, so my rate here is -3/2. And you can see that that is consistent. If I tried that again, so here 9 and -6, 9 divided by -6, oh, sorry, I get that same thing. -13.5 divided by 9. So that's just a really quick way to get R, is just take any future term, divide it by a previous term. All right, so here it is -3/2, or you could call that -1.5. Either way is acceptable. So recursive. Start with your first term, and then what's happening between terms? Well, I take the term before it, and I'm multiplying by -3/2. Now, I want you to notice what's happening. When you have a negative rate, the interesting thing is notice every other term is negative. It's flip-flopping signs because of that negative. So that's something to watch for, okay? Is if you notice a term or a sequence is alternating like that between positive and negative, that means it has to be geometric. If you know it's either arithmetic or geometric, you know it's going to be geometric, and you know that you're going to have a negative rate. That's how it flip-flops like that. And my explicit, take the first term times the rate to the n minus 1 power. So there's the basic construct that we're talking about. Well, just like before, when you're looking for the nth term of a geometric sequence, you're going to ultimately end up using the explicit formula. So for each of the following, we want to find their recursive formula, explicit formula, and then use that explicit formula to find A6. All right, so this first one, again, I started off with something basic. Well, I think here it's pretty clear that we're multiplying by 3. All right, so recursive, the recursive formula, you have to start by labeling that first term, and then you have to show that to get to any previous or any term, you take the previous term, and in this case, I'm just multiplying it by 3. Explicit formula, and again, explicit formula, this one's really nice and simple. Take the first term, multiplied by the rate to the n minus 1 power. So if I want A6, I'm going to use that explicit formula. 4 times 3, well, if I want n minus 1, 6 minus 1 is 5, okay? And now just plug that in to a calculator. 4 times 3 to the 5th power, 972. All right, what about this next one? So the next one looks like dividing by 2. But again, we can't think of it as dividing by 2. We have to think of it in terms of multiplication. So what am I really multiplying by? Well, I'm multiplying by a half. Okay? So my recursive definition, I always need that first term. Okay? That is a must. That first term, and then I need to say to get to any term, I take the term before it and I multiply by a half. Explicit. I take that first term, multiply by 1/2 to the n minus 1 power. So to get to the 6th term, again, use that formula. Use the explicit one. 10 times 1/2. And again, if I'm looking for the 6th power, n minus 1, 6 minus 1 would be 5. So let's type that into the calculator. 10 times 1/2 to the 5th, whoops, to the 5th power. Now I'm getting 0.3125, and if we want that as a fraction, just math bracket. So we're talking about 5/16. All right, so either 0.3125 or 5/16 is our answer. All right, this next one. So here's an example that I put in where, again, it's not as obvious what we're multiplying or dividing by. Okay, so let's run that little test. Remember, to see how we're going from term to term, take the future term and divide it by the first term. So 24 divided by 36. 24 divided by 36 gives me 0.6666 repeating. Again, I want to be as precise as possible, so let's turn that into a fraction. So that gives me 2/3. Now, let's just be confident that that's what we should be getting. So let's try the next one, just to make sure that the rate is actually 2/3. So 16 divided by 24. Let's make sure we get the same thing. And we do. So that is the rate that we're looking for. And again, I do want it as a fraction in this case because I want to be as precise as possible, so I don't want to approximate with a repeating decimal. Okay? I want the actual fraction. That is very important that you get me the actual fraction. So, recursive. I need that first term of 36. And what am I doing to go to the next term? Well, I take the previous term and I multiply by that rate of 2/3. Explicitly, an is going to be that first term, 36, times the rate to the n minus 1 power. And of course, if I want a to the 6, all I do is I plug it in here. N minus 1, 6 minus 1 is still 5. So let's plug that into the calculator. 36 times 2/3 to the 5th power. Now, again, I see a repeating nasty decimal. All right, so I'm not going to want to keep it like that. I'm going to math frac that so I can have a precise answer. Okay, so I really want that 128 over 27. Okay, I want to be as precise as possible. Okay, so please, when possible, always turn it back into its fraction instead of writing a repeating decimal. Okay, I don't want those repeating decimals. All right, next example. So here, I notice it's alternating. So that tells me right away that I'm going to be dealing with a negative R, a negative ratio. So it looks like dividing by 2, but again, we can't actually put into the formula dividing by 2. So what I need to put in the formula is that I'm multiplying by negative 1/2. All right? Always think in terms of multiplying. So what does that make my recursive formula? Well, recursively, I label my first term as 40. Then how am I going between terms? Well, all I'm doing is taking the previous term and multiplying by that rate of negative 1/2 that we found. The explicit, take that first term, I'm going to multiply by that negative 1/2 to the n minus 1 power. A6, of course, using the explicit formula, 40 times negative 1/2, 6 minus 5, or 6 minus 1, gives me 5. So let's plug that in to the calculator. 40 times negative 1/2 to the 5th power. So here, negative 1.25. Now, because that's a terminating decimal, because it has an end, that is perfectly fine to give me negative 1.25, okay? That decimal is exact. It has that end. But of course, if you'd like, just math frac it, and it will give you negative 5/4. And you could also give me that one. Again, when the decimal has a nice end is when you can leave it like this for me. All right, moving right along. So, physics. When a ball bounces, the heights of the consecutive bounces form a geometric sequence. What are the heights of the 4th and 5th bounces? All right, so the first thing we need is R. Well, remember that little trick, okay? To find R, I take a future term and divide it by a previous term. So my R here is going to be 7/10. All right. Now, if I'm going to find a future term, remember which formula is useful for finding the future? Well, the explicit formula is important for finding the future. So I'm going to construct an explicit formula. My first term times 7/10 to the n minus 1 power. Okay, so now that I have my explicit formula, if I want the 4th bounce, A4 is going to be 100, times 7/10. 4 minus 1 gives me 3. So I'm getting 100 times 7/10 to the third. And the decimal has an end, so I can just leave it as 34.3. They want the fifth bounce. Plug it into the same formula, but this time 5 minus 1 gives me 4. So let's plug that in to the calculator. 107/10 to the 4. The next one will be 24.01 centimeters. All right, so that's how you deal with any word problems that are asking about future terms. Always go to the explicit, okay? So always going to be that explicit one that you're looking for. Excellent. All right. Thank you for joining me for all of that. I'm hoping you enjoyed this. Again, I think the formulas are even better than the ones that we did in the previous section. So please write down your summary. Some key things you could talk about are how to tell the difference between arithmetic and geometric. How do you create an alternating sequence? All those kind of things would be great things to include in that summary. So make sure you write something for me and then come back ready to do your practice work.